This is a low-budget gaming PC with an i7-4790, and this is Intel's stock cooler. Pretty basic, right? But this is a super cheap RGB cooler from AliExpress. We all know the power of RGB and how it adds more FPS to the games. But the real question is, can something this cheap actually beat the stock cooler with thermals? Or is it just the cool looks and a waste of money? Today, we're putting them head to head to find out the truth and answer those questions. If you've ever wondered whether upgrading your cooler for cheap is worth it, you do not want to miss this. The tests will be divided into 3 categories: realistic gaming test, CPU's real-world performance test using Cinebench, and a synthetic stress test for CPU torture test using Prime 95, which is the worst-case scenario in thermal aspect. Let's begin.
Gaming test.
For this particular test, I intentionally chose Mafia 3 because, in my experience across 15 modern games, it has been the most CPU-intensive one I've played on this low-budget build so far.
What if the plane crashes? What if the train's delayed? What if they call him back? And he goes stand in front of the kitchen window and sip his whiskey like he was expecting you to come strong.
As you can see, on your left, Intel's stock cooler is performing well, averaging around 70 degrees Celsius. Let's now see how the aftermarket cooler is doing.
Sammy's doing alright. Ever since we got your telegram about coming home, he's been climbing the walls. What if the plane crashes? What if the train? A month back, Marty drops me a line that says, fuck it, it's your car, bash it up all you want. Anyway, anyhow, a month back, Marty drops me all over Frisco, just selling the French wall. George's Uncle Lou won't say shit as long as we give him a taste of the...
Under the same workload, the aftermarket cooler performs slightly better, averaging around 66 degrees Celsius, which is about 4 degrees cooler than the CPU temperatures with Intel's stock cooler. The difference isn't huge, but it's still noticeable during this gaming test. Both measurements were taken at a room temperature of 21 degrees Celsius and lasted for at least 15 minutes of gaming to collect enough average data. Let's move on to the next test.
Performance test.
In this test, I'll be using 2 applications, Cinebench and Hardware Info. The latter will display CPU temperatures and stats in real time, while Cinebench measures real-world CPU performance using 3D rendering tasks. First, we're running a multi-core benchmark, so we can see and compare the temperatures these 2 CPU coolers maintain under multi-threaded workloads, such as video rendering, encoding, and other professional tasks. The test lasts 10 minutes, so I'm going to fast forward to the end and check the results, first with the stock cooler, then with the aftermarket cooler, and compare both. Stock cooler. Aftermarket cooler. Here you can see the final results from the multi-core test in Cinebench. Let's look at the average CPU package temperatures for comparison. 78 degrees Celsius on the left with Intel stock cooler versus 64 degrees on the right with the cheap RGB cooler, an easy win for the aftermarket option. Looking at the maximum core temperatures, the CPU reached 85 degrees with the stock cooler, while it hit a maximum of 78 degrees with the AliExpress cooler. Now you can see the results from single-core tests. Similar advantage here for the cheap replacement. Let's move on to the final test.
Torture test.
The torture test in Prime 95 is designed to push the CPU to its limits by running a series of calculations that fully utilize all available cores and threads. It operates by running intensive mathematical computations, effectively simulating a worst-case scenario for computational workloads. This makes it an excellent tool for testing the performance of CPU coolers. After 20 minutes of heavy loads, here are the results for both sides. It might seem a little confusing and controversial, but the stock cooler actually shows a slight advantage in temperatures at this point, suggesting it maintains a bit more stability over longer sustained loads, even though earlier results favored the aftermarket cooler. There is a logical explanation for that. It can happen because the stock cooler is likely throttling earlier and more aggressively, keeping the CPU at slightly lower clock speeds. Lower clocks mean less heat output, which can result in marginally better temperatures over time. On the other hand, the aftermarket cooler may allow the CPU to boost higher for longer, generating more heat, which can lead to slightly higher temperatures and a different throttling behavior. So even though the stock cooler looks a bit better in temperatures here, it's not necessarily delivering better performance, it's just holding the CPU back a bit more to keep things cooler. Overall, neither cooling solution is sufficient to handle such heavy CPU loads, and the difference between them is negligible.
Conclusion.
So, after all the tests, gaming, real-world workloads, and even the brutal stress test, the conclusion is pretty clear. The aftermarket cooler consistently delivered better results where it actually matters. In gaming and everyday use, it kept the CPU noticeably cooler by around 7 to 8 degrees, which is a solid improvement. The stress test results might seem a bit controversial at first, but as we explained, there's a logical reason behind that behavior and it doesn't take away from its real-world performance. For the price, this cheap cooler is honestly a great value. You're getting better thermals, slightly quieter operation compared to the Intel stock cooler, and a much nicer look thanks to the RGB. So if you're wondering whether it's worth upgrading from the stock cooler, the answer is simple: yes, absolutely. It's a small investment that brings real benefits in performance, noise, and aesthetics.